plus, well, I pulled cosine x out of here, so we're left with cosine squared x all over sine x. Well, sine squared plus cosine squared, I hope by now you recognize equals 1. And so we just be left with cosine x over sine x, which just equals cotangent x. Stuff going on here. Which would equal cotangent x, which equals cotangent x, and we are good. Another method. Let's do another method. All right. What I might look at is another method. Oh. And then once we did this one, we'll do another one, all right? All right, so the other method, everything's written in cosine on the top, except for sine squared. You can write sine squared in terms of cosine, because sine squared equals 1 minus cosine squared x. So you could replace this sine squared with 1 minus cosine squared. You can do that anytime. So rewriting this one, we would have cosine x is probably a really good idea for you guys to turn off your phones today.
It's not.
I know. I'm just saying it's probably a really good idea for you guys to turn off your phones today. Because there's going to be a lot of Amber Alerts. So we're going to replace that sine x squared plus cosine cubed x all over sine x. So all I did is I replaced that sine squared x with 1 minus cosine squared x, which when we distribute it, we'd have cosine x minus cosine cubed x plus cosine cubed x all over sine x. And all of this stuff would cancel out. You just be left with cosine over sine, which equals cotangent. Which way is easier? The first one is easier. That's why I did that one first. But there are going to be times when you're doing proofs that you're not going to pick the easy method. And you're just going to have to keep going. All right. So when we're doing a lot of these identities and stuff, there's going to be multiple ways to do it. Just keep working at it. And if you come to a complete dead end, that's when you stop and go back. All right, questions on this one? Okay. Then let's just go over homework questions. Russ. 53 was 53. It was the tricky note one?
Yeah.
I think I actually put the note in your stuff too. All right, so we are given sine squared negative x minus sine of negative x all over 1 minus sine of negative x. All right, all these negatives we could pull up front because that was our odd even identity. That sine, if you have negative sign in parentheses, you bring it out front, which will turn this into a positive and turn this into a positive. Did you have a question on the note, or?
I understood that, but then on the second step, you got +1 somewhere.
I just want to make sure so you understand why we went to just regular sine squared x.
Yeah.
Okay.
Yeah, I got that far.
And then we have plus sine x.
Yeah.
all over 1 plus sine x. So you're okay there?
Yeah, I got that. Yeah.
Oh, okay. Now what I'm going to do is I'm going to recognize it's kind of like our bell work, where I have sine in both elements in our numerator. So I'm going to factor it out.
Oh.
I'm going to factor it out to being sine, and sine squared x divided by sine would just be sine of x left over. And sine x, when I'm pulling it out, will just be that plus 1. And this would actually, I'm just going to alter the bottom to look like sine x plus 1, where those cancel out. So all I did is I factored out a sine x out of both elements. It's always a good trick to notice if it's in every part of the elements. It's a nice, easy way to solve a lot of these.
And then from there, get the sine x plus 1 cancel out.
Yep.
And that's just sine x.
And then it's just sine x. Yep.
I was just confused where you got the plus 1 from.
I factored out. Yeah, it kind of looks like I didn't draw any pictures or anything. Notice how factoring out something appears a lot? Might be something you pick up on. All right, Mark.
51.
51. Specific question or just the whole thing?
The whole thing.
Whole thing. Okay. So 51. 51, we were given sine squared x minus sine of x minus 2 all over sine squared x minus 4. Let me rewrite that. Let me rewrite it in terms of x. What we have is x squared minus x minus 2 on top. And on bottom we have x squared minus, I'm going to rewrite the 4 as 2 squared. So this is a trinomial, and this is a difference of squares. So I can rewrite that trinomial as 2 binomials, so I'm going to factor that top, which will give me x times x gives me my first thing. What can give me my 2 would be a 2 and a 1. It's going to be negative 1 in the middle, so I'll have minus 2 plus 1. And it'll be all over a difference of squares turns into x minus 2, x plus 2. All right, how that would look with sine is we would just have sine of x minus 2 times sine of x plus 1 all over sine of x minus 2 sine of x plus 2. Are you okay where I got all that from now, Mark? You sure? All right. Then this would just cancel out with this, and the complete simplified form is just sine of x plus 1 over sine of x plus 2. There's no way to simplify it. We don't have any identities with just sine of x. It'd have to be sine squared x. Other questions? All right. Hope. 65. So 65 is probably the tougher of the ones. Because 65, you end up having to work on both sides. Not at the same time, but independently. So 65, we had 1 over cosecant theta minus cotangent theta is going to equal 1 plus cosine theta over sine theta. All right, so I'm looking at the left-hand side, and I'm looking at it and I'm saying, well, I can rewrite that as cosecant would be 1 over sine, cotangent would be cosine over sine, and then we have 1 over it. So maybe we'll start with that side. We'll start with the left-hand side. So we are going to have 1 over sine theta minus cotangent would be cosine theta over sine theta. I don't like having fractions over fractions, and there's no way to break it apart to say it's reciprocal. Like if this was just 1 over sine theta, I could just flip it and just have sine theta. But we can't do that because it's in the denominator. There's no way to break it up. So the easy way to get rid of fractions, if you have fractions in the denominator, is to actually multiply your denominator by sine theta. But you're not allowed to just multiply the denominator by sine theta. You have to multiply the top as well. So we'll multiply the top by sine theta. So we're really multiplying by the fraction 1. Well, when I distribute the sine theta to both of these, and we distribute that to there, we're going to be left with sine theta over, well, sine theta over sine theta is just going to be 1, minus the sine thetas will cancel out, 1 minus cosine theta.
Oh, and I got that on the other side. Because I could do the right side, but I don't know how to figure out the left side.
You can actually do this all on one side if you want to, too. Because now I could multiply the top and bottom by 1 plus cosine, and I could just kind of go.
Oh, no, I'm talking about like the 1 plus cosine theta over sine theta.
Mm-hmm. You got it to equal this? Yeah. Okay, good. Good. No, I was saying another way you could have done this. Another way you could have done this is multiply this one by 1 plus cosine on top and bottom, because this would also be a sign that I need the conjugate. So this one you could have worked on both sides. I like to, as soon as I get here, it's kind of like a nice stopping point. Then look over here if I could do something over here. Does that make sense?
Yeah.
Cool. Cool. So? Yeah. So on this problem, what I might do, the reason why I start with this side is sometimes I just start with the conjugate, and I work down, I got to like a stopping point. That's why I worked over here. But if you pick this side to start on, your next step could be multiply the bottom by 1 plus cosine theta. Multiply the top by 1 cosine theta. Not plus, multiply. The whole point of multiplying by the conjugate is that I end up with 1 squared minus cosine squared, which equals sine squared. So the whole point of doing this is to get sine squared on the bottom. So we'd end up with 1 plus cosine theta times sine theta on the top, and on the bottom we'd have sine squared theta, your sine, and that would cancel out, and you'd actually be left with the other side. There's always multiple ways, and I don't always pick the easy one in my answer key. I try to pick the ones that show key steps along the way. So like on this one, I picked going on the other side. Basically because generally speaking, if I see a conjugate, I'll multiply by the conjugate to start off with. So it might have been easier to pick the left-hand side first. It is just a couple less steps. Mark?
So they want to have a question about the factoring.
Okay.
How do you factor out a 1 minus cosine squared W?
You don't.
What do you factor out?
Oh, I have to go further than that? No, I'm just kidding. I see what you're looking at. So we had sine to the 4th W equals 1 minus cosine squared W plus cosine squared W times cotangent squared W all over so many W's. Cosecant squared W. All right. Mark, forget about that. We're going to treat it as it's just going to hang out in front all by itself. We're not doing anything with that 1 minus.
You do that, though.
Just forget about it for a second.
Okay.
Just focus on this thing. In fact, I'm going to make it disappear. It's gone. So now I'm going to look at the fact that we have cosine W and cosine squared w there. So I'm going to, did I put something wrong?
Yeah.
Oh, it's cotangent. Okay, thanks. It is hilarious putting a T instead of an S. All right, so we have cotangent, and we have cotangent squared there. So that means I can pull a cotangent squared out of both of those elements. So I can rewrite that numerator as cotangent squared w. We're left with 1 there, because I am pulling it out. I'm leaving a 1 in its place. Plus cosine squared w all over cosecant squared w. But in the original problem, we had 1 minus. Well, that doesn't change anything. We'll still have 1 minus. The only problem is you have to worry about your sign now. See how now it's 1 minus? When I distribute this negative cotangent squared w, I would get out negative cotangent squared w, right, if I distributed this. But then I would get a negative cosine cotangent here. Do you get what I'm saying? If I went backwards? Did I lose you?
A little bit.
Okay, picture factoring this back in to see if it gets out the original. Okay?
Oh, I see.
So what do I need to change the sign to?
Yeah, it would be.
It'd be a negative. So you're not really concerned about that 1. That 1 just hangs out in front. I'm not doing anything with it. Everything that's happening is just this part here.
Okay.
I'm factoring out just that part. Leave that 1 out front. Because, let's forget about that 1 for just a second. And just the negative sign. This is negative cotangent squared. Negative cotangent squared times 1 gives me back out my negative cotangent squared. Negative cotangent times that would give me back my positive back out. It has to be positive. Yeah. Let's bring that 1 back in. All right, so the first thing I'm going to notice is 1 minus cosine squared is actually equal to sine, right? Okay with that? Yeah, Russ.
Is 1 minus cotangent squared equals tangent, or am I wrong?
1 minus cosine
Cotangent
squared.
squared equal tangent.
Oh, we can't do anything yet with that.
Oh, why?
I don't think I did anything with that right off the bat, did I?
I don't know.
No, I didn't do it. Because it's being multiplied. If it was the quantity being multiplied, then you could change it. But see, it's not really the quantity, it's just the negative. That 1's just hanging out there for right now. All right, so that equals sine squared. So that would equal 1 minus, and see how that's sine squared, Safa?
Yeah.
I'm going to change that cotangent out front to be cosine over sine, because it's always a good idea if I have sine on top to change everything into terms of sine. So I'm going to change that cotangent into cosine squared w over sine squared w times sine squared all over, I guess I'll just leave it with cosecant for right now. Cosecant squared w. Well, our sines are going to cancel out. And you'll be left with 1 minus cosine squared, which equals sine squared. And then you'll be able to do something with that cosecant squared and sine squared. I think that's as far as I'm going to go with it, though.
Yeah, no, I got it.
Because you should be able to finish this off. Other questions? Safa? Say that again. He was coughing right in my ear. 61. All right. A specific question or just how to do it? So this is one of those that you need to factor. You need to factor something out. So look at that sine cubed. That sine cubed is basically just what we did for our bell work, and we're probably going to do another example today or something like it. That I'm noticing that we have sine cubed, and I have sine here. So that means factor out a sine x out front. Which once you do that, you're left with sine squared plus cosine squared inside, which just equals 1. And then you have sine x over cosine x, which is just tangent x. But you have to recognize to factor that out. Once again, you could have changed cosine squared to 1 minus sine squared, and it all would have worked out just like in the bell work today. Other questions? Russ?
Could you just like go through 69?
Yeah. So I guess the big thing about number 69 is that you have a difference of squares. You actually have a difference of squares there. So once I get rid of those negative signs, so first of all, this is, anytime it's squared, this just turns positive, just like that one hint has. So I have 1 minus sine squared x on top, 1 plus. Well, this is 1 squared minus sine squared, which is a difference of squares. That is a squared minus b squared. So I went ahead and you may have turned it into cosine squared.
I had trouble with it.
Okay.
Yeah.
Because this, you might think to yourself, turn it to cosine squared, but if you look down here, I'm like, I want to keep it in terms of sine.
Yeah. Okay.
So I just changed it to 1 squared minus sine squared. Difference of squares is a minus b times a plus b. Well, when you do that, you have 1 minus sine times 1 plus sine. Our 1 plus sine will cancel out with our 1 plus sine here, and I'm just left with 1 minus sine x.
Okay. Yeah.
Because this is a chain of multiplications. In a chain of multiplications, you can cancel out the denominator if it matches the entirety of the chain.
All right. Thanks.
Yeah. Mary? Yeah. Other questions? Okay, like I said, the lesson today is super, super quick. It's just 2 quick examples. First of all, you have your own sheets to check if you did that correct. We're just going to verify these 2, and then you'll be free to work the rest of the time. So it says verify the following are identities. So as a reminder, you kind of wall this off and say, well, I can't multiply both sides, can't divide stuff on both sides. I have to work independently on each side. I'm going to start with the left-hand side because it's definitely the more complicated of the ones. And I'm going to notice that I want things at the end of the day to be in terms of sine. Knowing that, it's probably a good idea to change everything into terms of sine and cosine and hope stuff cancels out. So the first thing I'm going to change is that tangent value. Instead of tangent, well, cotangent is cosine over sine, so tangent must be sine theta over cosine theta times that cosine theta plus cosecant is 1 over sine theta times that sine squared theta. Well, that sine theta over cosine theta times cosine theta. Remember, cosine theta is really cosine over 1. Well, the cosines are going to cancel out. Here I have sine squared divided by sine, which will cancel out that bottom sine squared and turn that into just sine theta on top. And we'll be left with sine theta plus sine theta. I have 2 sine theta, so that's just going to be 2 sine theta. Well, that's exactly what I had on this side. So I think the point of this problem is sometimes it's a good idea to see what it needs to equal to tell you what you need to do. I saw sine on this side, so it just said turn as much as you can into sine and cosine and see if stuff cancels out. That is the good sign of that right-hand side. All right, this one. Once again, you're going to build, how much work do I have to? I don't think I have to do that much work. We're just going to build that huge wall across there. All right, we have secant squared over 1 minus secant squared. Which way did I pick to go with this? Actually, do I care? Probably not. All right, we have secant squared over 1 minus secant squared. What's 1 minus secant squared equal? Does that equal anything? Emma? Negative tangent. Now, I'm not telling you to write that down. It might be a good step to go that way. But look at the other side. Does the other side have anything to do with tangent? Anything to do with? It's got nothing to do with tangent. So although this equals negative tangent, it could work. I mean, there's nothing wrong with it. There's nothing wrong with that idea. And in fact, if you go down that route, you'll probably get to the correct answer. But an alternative is to go, all right, cosecant, that's 1 over sine. I know I could turn this into cosine. And I know if I get cosine squared, I can usually turn that into sine. So I'm thinking, let's change that left-hand side to cosine values. Let's change that left-hand side to cosine values and kind of see where it takes us. If I get stuck, then I go back and I go back to that negative tangent. Because Emma, that negative tangent, I could turn that into negative sine over cosine too, right? So that method would work too. But I'm using that right-hand side to guide me, to tell me, hey, change those secants into 1 over cosines. So let's try that. And if it doesn't work, we'll do something else. So we have 1 over cosine squared theta on top. On the bottom, we have 1 minus 1 over cosine squared theta. I don't like fractions in the numerator. I don't like them in the denominator at the same time. And because it's in the denominator, the easiest way to clear that out is to multiply the top and bottom by cosine squared theta. So multiply the top by cosine squared theta, multiply the bottom by cosine squared theta. Now when I distribute this here, distribute the denominator to both places because it's the entire quantity, we're going to have cosine squared over cosine squared in the numerator, which just turns to 1. In the denominator, I'm going to have cosine squared minus cosine squared over cosine squared is just 1. What's cosine squared minus 1? Careful with it. There? Close. It'd be negative sine squared. Because let's look on the, so if I, remember on the test or something, always write out sine squared x plus cosine squared equals 1, and ask yourself what would have to happen. I would have to subtract 1 from both sides to get cosine squared minus 1, and I would need to subtract sine squared, so that would equal 1 over negative sine squared x, which is negative cosecant squared x, which equals that negative cosine squared x, and we are good to go. So these are both just really good examples of using the right side to help guide you on what you need to do on the left-hand side. I ended up with cosecants, so it's probably a good idea to have sines. If this was like cotangent or something, then it'd be a good idea to use that tangent right off the bat. All right, so use that right side to kind of show you what you should do on the other side. All right, questions for me? Okay, then the rest of the time is for you to work. It's just more problems. More problems.